Hey, so the ongoing lots of power meter things is still ongoing. Here we have another one. This is a Belkin Conserve Insight. Blah, blah, blah. This one's actually, I think, a lot nicer designed than the kilowatts, at least kind of in a very basic way, because as you can see, the readout is physically separate from the, basically the actual monitor by, as you can see, probably looks to be about 4 feet of cord. Which I think is that's about 5 feet actually. So, the nice thing therefore is that this can sit, it's actually designed, that's why it's got this big pip on the back, to sit on a table kind of like so, whereas this is down underneath something. But, yeah, it's just another, kind of more market research at this point. I'm buying a few of these just to see what they are internally and kind of get an idea of how other people do this so that I can implement my own better. Anyways, so as you can see, it's got 4 security bits because they're assholes, triangle, and this has no screw holes at all. You can kind of see what the display looks like. It's got buttons. Oh yeah. I can't get the sticker off. There it goes. So apparently there's nothing plugged in it. It's drawing negative 0.5 watts. That makes my day. That's hilarious. And the buttons don't do anything. Oh, quality. Let's see. I think that is one of my workbench lamps. I think this is a 60-watt incandescent. Now it's doing something. I don't know. It looks like it's dollars. Oh bother, it's got stupid ass CO2 shit. 67.5 watt. I don't know where that number came from. It might be $68 if it's run continuously for the entire year. Let's see. Oh yeah, and then you have to set the power, the kilowatt hour. I wonder what the number they're using for the CO2. Oh yeah, there you go, 12 per kilowatt hour. That's pretty funny. You can set it from, you can change it to metric. Oops. I wonder what the little ticker tape is. I guess that could be like a, kind of like the spinny disc that is common in, in actual meters. Like, I wonder if it's proportional to this power draw. Don't have another load I can plug in conveniently. Oh wait, no, that couldn't really plug that in with it. Well, yeah, I guess it could. Yes, no, yes, no. Oh yeah. This is a fluorescent. Let me plug the incandescent back into the cord where it normally goes. And this should be I think a 17-watt fluorescent. Yeah, so that's intended to be like a little ticker that shows you the rate of power consumption kind of as a visual thing. Kind of a silly little widget, but what can I say? Fair amount of jitter in the measurements. So I guess the fluorescent could be warming up. This is a really horrible China fluorescent too. So the power factor, it has no power factor correction whatsoever. So depending on how they're sampling the current draw, the error could be very inaccurate. If they're just doing like quadrature sampling 4 points in the waveform, it would not produce an accurate result. Anyways, let's have a look inside, see if I can actually figure out how to get this thing open. Let's see if I can fit a slotted screwdriver into the triangle holes. One thing of note, I don't know if you might have seen this, but this is apparently 60 Hz, 800 watts Cat 2. It's Cat 2 rated apparently. It's also not CE rated, it's just FCC and RoHS. So there we are. Wow, look at this. We already have interesting. Look at that brass forming. So I guess that's how they're breaking in. So I would bet that this tine goes straight through and forms the socket on the other side, whereas this tine, because they need to break the connection to stick their current shunt in there, folds over and then there's the current shunt and then it goes out. You can also see that we have a crystal here. This is 3.57945 Hertz. And this whole thing is very stuck. Yeah, it's just pressed in, or glued in, possibly from the popping noise. Okay, so, yeah, it was glue. So here is our power supply. We have a good old-fashioned capacitive dropper. There's our current shunt. There's the current monitoring IC. Wow, this is interesting. This is using an ADE 7753. So this is using an off-the-shelf analog devices power meter. Oh, and that could be a potential. Let me change lenses real quick. So here's the board. You can see that is an ADE 7753, just an analog devices. That's a power meter IC from ADE, right off the shelf. So you've got here are your crystal load caps. It's interesting, this is some big ceramics. Let's see, here's the glue that held the thing into the casing. Now this concerns me. I guess it must not be an issue, but you can see here, here's the power supply, and look at this. The leads of these components are touching. I mean, I guess it's not an issue, but that rather poor quality control if nothing else. And, well, it's also bad component placement that could even happen. So my guess is that, you know, so this is your So I've been studying this a little more. So what happens is, so you have line run to the MOV, and then this runs straight up to the neutral input, whereas the capacitor goes through D1, and then on the bottom side is a Zener diode to ground, and then on the, so it runs past the Zener diode, and then this is the positive terminal of this big capacitor here. So it's a standard capacitive dropper. This is a JAYE. Never even heard of them before. So it's a no-brand, no-name capacitor, 25-volt cap. And then we have resistor, a ZD2, and a transistor. So I bet this is a little cheapo, low, pass regulator, much like the one I saw in the kilowatt. We have a bunch of passes over here. Now this is interesting. Look at this little boondoggle here. So, can you say board error? Look at how it appears they've lifted the pad here, tacked this resistor from here to this wire terminal, and then put a diode or some sort of chip here. Where, remember, the ADE 7753 is right over here. So that's quite amusing. And you can see these are these big solder blobs are the current shunt, which is that right there. So another thing you might notice is, see right there, that little divot in the current shunt? That's their tuning. So that's basically they put a current through it and then they whack it with a file. It looks like they might have also whacked it over here to basically change the resistance very slightly so that it comes into calibration, or it can calibrate. This is interesting. This cable is many conductor. This is a 6-conductor cable running to the little display. The one thing I have noticed is I don't see the mains potential divider on here. It could be R1. So this is R1. But the only... some big copper pores. That's neutral. It could be that. It's either that or it could be that resistor here. This 514 is the discharger across the ceramic cap and the cap, or the film cap and the cap dropper. So that's basically just to be sure that this falls to a safe value with, in a fairly short period of time, so you can't shock yourself on the pins or anything. But yeah, so we have mains comes in there. I don't see how it could get to the other end of the MOV. They could also be doing something else clever, like sampling it on the output of the cap dropper. I'm not entirely certain. Now this is, you can see it was made by a company called CC Tech CD1, Shenwei Ltd, version 1.03, and it's still, this is the frickin' third rev, and they still have horrible hacks and terrible soldering quality, incidentally. Look at how bad the soldering is. It's just the board is filthy and covered in flux. On the other hand, one thing I noticed that was interesting about these is the price of this is very volatile. It was $20 on Amazon, and then it was $26, and now it's $30. Also, how reliable can that ground? I mean, it's not like the power connections, which have 2 connections. The ground is just a single spring. I don't really know if I'd trust that. Just sits into there. Change lenses again. This whole thing just kind of sits down a little bit. The glue is now in the way because that's what glue does. Makes things difficult. Oh fuck, I'm a dumbass. Yes, we have retaining screws. Why would it only be half snap? So I guess this comes off, yep. I didn't even... I'm stupid. Alright, anyways, derpitude aside. I will kind of put this back together, maybe not in perfect working order anymore, but to the extent which I can. I reapply the sticker. So, you can see one of the nice things is that it's got an LCD with like probably a zebra strip on there, but it's not, just held in by the casing, which is a step up from something like the Kilowatt. Especially considering it's the same price point. It's pretty impressive, right? Alright. That is the casing with its sticky tape on it off. So, there is hardly anything in there. Now that's interesting, we have a whole second crystal in here. So, crystal, EEPROM, couple surface mount devices, and a cob. These things are all cob based. Back to the macro lens. So here is our board. One thing you can see is they've got plenty of strain relief and epoxy. Or that's actually not epoxy, it's silicone. But I wouldn't worry about yanking on that cable, that's quite well made. US. So, we have a annoying cob. That's quite nice. It's a 50-pin device, wow. So, I haven't seen this before. Pin 1 here, 2, 17, 18, 33, 34, 49, 50. So I guess they're probably like a circle of wire bond pads underneath this epoxy. It's a fairly well controlled epoxy application too. It's not like a lot of them where they're just going to glob it on. This is a 24CO2, that is an EEPROM for the CAL. I guess this must be an OTP device, and then the CAL is stored externally. That's intriguing. Or the CAL and whatever else, you know, the price per kilowatt and so forth. Q1, you can see they've kind of made a mess with the silicone. So this has got to just be probably power, ground, SDI, SGO, S-clock, and CS, I would imagine. Because again, I think that the analog device's power meter device in there is indeed it's an SPI device rather than like I2C or something that's lower pin count. It could also be like SPI and then, or excuse me, it could also be like I2C and then there's the like the power consumption thing where there's a lot of these are designed for going into situations where they, there's like a pin that toggles state every certain amount of power consumption, so that could be one of the things routed along here. Other than that, you've got some unpopulated passives. I wonder what some of this stuff is an option for. There's your crystal, C8.00, and then you just have the loading caps, ground and VCC. Well, that's nice of them. They've even labeled it. And then back on the front side, you just have the buttons, which are actually like metal dome buttons, which is quite nice, which means they're really satisfying and clicky. The logo, PGM100162, parentheses Conserve Insight MCU. Version 1.03 again, 94V00. And then I'm just going to plop it back together and feel kind of clever about totally fucking up the casing and move on. Man, I just was confused by the fact that they use a mixture of snap and screws. And honestly, I didn't expect them to be using screws considering the price point. So, well, you assume you make an ass of yourself. That's what I get, make an ass of myself. So this is actually quite interesting. So if you're like interested in hacking something, probably this thing would be excellent because it uses an energy meter IC, which is very well documented. I mean, you can just go grab the analog device's datasheet if you're so inclined without any, no trouble. So this is very, very hackable. I mean, all of these things are kind of a challenge to work on just due to the fact that they're all mains connected. But in the scale of, like the kilowatt with its, direct conversion, or the, one of the other power meters are taken apart with its unbranded power meter IC. This has got, big name silicon by, companies that'll actually produce, make data sheets available. So this is definitely the way to go if you want to play with one of these. I'm just amused by the fact that, I mean, this is reading negative 0.5 watts. Which means that they have to have put the facility to read negative watts into the firmware. Why? I mean, is this intended to be used in situations where you're back driving power into the mains? Just what? I'm amused. That amuses me to no end. And also, apparently the buttons don't do anything when there's no power drawn, which is even stranger. But there you go. We'll back together and hoity-toity again.